All right, so the notes that we're going to be doing today are on stoichiometry. This is the packet that you need to have out, Chemistry Math Part 3. We've already done all of the first page. We've already done all the second page. Those were what your quiz was on last class. And what we're going to be doing today is this part on stoichiometry. When you finish with this, I will point out what worksheets you're going to be working on today in class, okay? So please get that out. You're also going to want to have a calculator out and a periodic table and obviously something to write with. If you need to put this on pause while you get those items out, do that. And I'm going to go ahead and pull up the PowerPoint. All right, so stoichiometry is a really big word for basically conversions. You actually have most likely done stoichiometry at some point in your life if you have ever done baking, because basically you use different amounts of substances to make something. And that's what we're doing when we use stoichiometry. We're converting between different substances. Sometimes they're in the same units. They could be in moles, they could be in grams, and sometimes they could be in different units. One could be in moles and one could be in grams. Our recipe is the balanced equations, what we've just been working on. The balanced equations relate the reactants and products to one another. And with stoichiometry, you will take two of the substances that are in your balanced equation. They could both be reactants, they could both be products, or they could be one reactant and one product. And you relate them to one another using that balanced equation. What allows us to relate them are the coefficients. They tell us how many moles we have of each reactant and each product that we need to have our reaction take place and use up all of our reactants and convert them into products. This is going to look a lot like what we did with mole conversions, and the only piece of reactions that we're going to need to solve stoichiometry problems are the coefficients in the balanced equation. So these steps are going to look really familiar. You've got to figure out what you're starting with. You do need to make sure you include the chemical formula of the substance that you're starting with, since you're not going to stay with just that particular substance. You're not just going to change moles of oxygen into grams of oxygen, or grams of carbon dioxide into moles of carbon dioxide. You could go from moles of oxygen to moles of carbon dioxide, or grams of carbon dioxide to grams of oxygen. So you need to make sure you include those chemical formulas, and you'll see that in the examples we're going to do. We set up our conversion factors just like we've always done, so that whatever we start with gets canceled out. You want to make sure you include, again, both the unit that you're working with as well as the chemical formula for your substance. And then we put the units and the chemical formula for the substance we're trying to find out about in our numerator. In our conversion factors, right now we're just going to be dealing with moles and grams, and we spent a fair amount of time on that at the beginning of January. Moles always gets 1, because that's what we define our quantities in terms of, 1 mole. And we know that the molar mass, using the periodic table and the atomic masses of our elements, can help us find the grams. The only thing we're going to add to what we've done previously is to relate the different quantities to one another, the different chemical substances, and those are when we use the coefficients. We multiply the chemical formula for the denominator in our conversion factor by the coefficient for that substance in the balanced equation, and we do the same thing for the numerator. At that point, we do math. We multiply all of our numerators together, we multiply all of our denominators together, and we divide the two values to come up with our final answer. Sig figs, again, are based on our starting value as well as our molar mass. The one that we see when we define 1 mole, as well as the coefficients, do not have sig figs. They have unlimited number of sig figs. They are defined quantities, exact values, and so only the molar mass and your starting value will affect the significant figures that you report in your final answer. So these 3 problems are worked out for you on your paper. This is a combustion reaction. It says we're taking the moles of carbon dioxide, and we want to find out about the moles of carbon dioxide while we're given the moles of ethane, 2.53. And y'all know what ethane is from when we did our molecular substances. That's the C2H6. You also know what carbon dioxide is, 1 carbon and 2 oxygen, CO2. So we're going to be going from C2H6 to CO2, and we're going to take the moles of ethane that we were given, the 2.53 moles, and we start that with what we're put that over 1, write down what we're given. We want to cancel out the moles of ethane, so they're going to go in our denominator. And we're going to place the moles of carbon dioxide, what we're looking for, in our numerator. Now on your paper, I put a 1 in front of each of these because we've always defined moles in terms of 1. And then I also said we need to account for the relationship between carbon dioxide, that there's 4 moles of carbon dioxide made for every 2 moles of ethane consumed. So the 2 goes in front of ethane, and the 4 goes in front of CO2. I did not include the 1s because anything times 1 is itself, so I just showed the coefficients there. You are more than welcome to put the 1s in if you so wish, like it has it on your paper. At this point, we cancel out the units that are in both the numerator and the denominator, the moles and the chemical formula for ethane, C2H6. We multiply 2.53 times 4, and then we divide it by 2. Again, these do not have sig figs, but the 2.53 does. So we would have 3 sig figs in our answer, and we would get a value of 5.06 moles of carbon dioxide. If you do not put CO2 with this, you would not be penalized, but you do need to make sure you include units. So this next problem is going to involve going from grams of oxygen, one of our products, to grams of potassium chloride, our other product. Okay? You have 4.68 grams of oxygen that was produced. Sorry, combustion did not occur in this reaction. That's an oopsie on my part. And we want to know how many grams of potassium chloride we are going to make. We know it's potassium chloride because we're told it was produced as opposed to being consumed, which would make it be this reactant over here on the left side of our equation. We want to cancel out our grams of oxygen, so they go in our denominator, and we place the grams of potassium chloride in our numerator. With grams, we need molar mass, so we would go and find oxygen on the periodic table, number 8, take its value 16 and double it to get 32. For potassium chloride, we would take 1 potassium at 39.1. That's number 19 on the table. And chlorine, number 17, and add 35.45 to it. This defines these in terms of 1 mole. And if we look at our balanced equation, we see that there are 2 moles of KCl made for every 3 moles of oxygen that are also made. So before we can solve our problem through, we need to account for that molar ratio by placing a 3, just like it is in front of oxygen in our balanced equation, in front of the O2 in our conversion factor, and the 2 that's in front of KCl needs to be placed in front of KCl's numerator in the conversion factor. I want you to notice you have 2 non-1 numbers in the denominator, so remember you need to put all of these in parentheses if you're going to do this calculation all at once. I would multiply 4.68 and 2 and 74.55 together. I would divide it by the product of 3 and 32, and then I'm going to look at sig figs. The grams of oxygen do cancel out since they're both in the numerator and denominator. In terms of sig figs, I have 3 sig figs in my starting value. My molar masses both have 4 sig figs, so I want to have 3 sig figs in my answer, and I got 7.27 grams. So we've done one with all going from moles of one substance to moles of another. We've done one going from grams of one substance to grams of another. We're going to combine them and do both moles and grams this time. Nothing changes. The problem gets solved exactly like we've done before. We still start with whatever we're given, which in this case is 2.58 moles of aluminum oxide. Now, aluminum oxide, that's 2 words, which means it's going to be a compound. And the only substance in our chemical equation that's a compound is the reactant, Al2O3. So I'm going to start by taking 2.58 moles of Al2O3 and placing it over 1. That's my starting value. I want to cancel out the moles of aluminum oxide, so they go in my denominator, and the grams of aluminum are going to go in my numerator. We've said that moles always gets 1, and that grams gets the molar mass of its chemical substance. So aluminum is number 13 on the table. It has a molar mass of 26.98. Again, I did not put the 1 in front of moles of aluminum oxide because anything times 1 is just itself, but you are welcome to write the 1 there if you so choose. And now I need to relate aluminum oxide to aluminum, account for their molar relationship in my conversion factor. So aluminum oxide is going to get a 2, and aluminum is going to get a 4. The moles of aluminum oxide cancel out. I multiply my three quantities in the numerator, 2.58, 4, and 26.98, and I divide by 1 times 2, which would be 2. My molar mass has 4 sig figs, 2.58 has 3 sig figs, so I want 3 sig figs in my answer, and I got 139 grams. All right, so we're going to do 3 now that aren't on your paper, so I'll give you all a chance to kind of see how this works out without having it written out for you. We're taking nitrogen and oxygen and making dinitrogen pentoxide. I want to know how many moles of oxygen gas, so that's going to be on my reactant side since O2 is over there, will react completely with 30 moles of nitrogen gas. So nitrogen being N2, I'm going to start by writing down what I'm given, and I'm hoping that if you take a second and write that down, you're going to see that that should be 30 moles of N2. Now, what do we go next? We want to cancel out what we started with. So in our denominator, we're going to want to cancel out the moles of nitrogen, and we're going to want to find whatever we're looking for, which in this case would be moles of oxygen. Again, moles would get a 1, and then you would multiply them by their coefficients from the balanced equation. Because oxygen has a 5 in front of it, 5 times 1 would give me 5 moles of oxygen. Nitrogen has a 2 in front of it, so 2 times 1 would give me 2 moles of nitrogen. The moles of nitrogen cancel, and I'm going to take 30 times 5, 150, and divide it by 2. The 30 is the only value that has sig figs in this problem. So since it has 2 sig figs, when I take 150 and divide it by 2, I get 75. I don't need to call that 75.0 or 75.00 because that would give me too many sig figs. The first page of problems you're going to work on today are just going to involve moles. So you're going from moles of one quantity to moles of another quantity. The second page of problems you're going to work on today are going from grams of one quantity to grams of another. What mass of water is made when 5 grams of hydrogen gas reacts with excess oxygen? I want you to notice this one requires you to balance the equation. I won't make you go from formulas to, words to formulas so much in this section, but I will at times ask you to balance an equation. And if we take a look at this, we see that the hydrogens are balanced to start with. Oxygen is not, so we're going to need a 2 in front of the H2O. Because we had to double the H2O, we doubled the hydrogen on the product side, so we also need to double the hydrogen on the reactant side. Always have to have a balanced equation to relate quantities, different chemical substances to one another in order to solve stoichiometry problems. Once we have our balanced equation, we can go ahead and write down what we're given, the 5 grams of hydrogen gas. Hydrogen, again, is by itself, so we're looking for the elemental form of it. We want to find out about water. So water is going to be on the product side. After we cancel out the grams of hydrogen in the denominator of our conversion factor, we're going to place the grams of water in the numerator, since that's what we're looking for. 1 mole of any substance, reminder, is equal to its molar mass in grams. So I would go to number 1 on the periodic table, take the molar mass of hydrogen to 2 decimal places, 1.01, and I would double it since it's H2, giving me a molar mass for H2 of 2.02. To get the molar mass of water, I would find oxygen, number 8, and add 16 to that 2.02 value, since there are 2 H's and 1 O, and the molar mass of water would be 18.02. Because water and hydrogen both have the same coefficient in front of their chemical substances, they're in a 2-to-2 ratio, which could simplify to 1-to-1. That's probably the most common thing people leave out are the coefficients in front of the chemical substances and their conversion factor. You always have to make sure that you relate the 2 substances that you're working with to one another via those coefficients. If it's the same value, then if you leave it out, it's not such a big deal. But if it's not, and it often is not, it's not going to give you the right answer. So please watch to make sure you include your coefficients. We would multiply 5 times 2 times 18.02. We'd multiply 2 times 2.02, and then we would divide those 2 values. The grams of hydrogen did cancel out. 5.0 has 2 sig figs, The molar mass for water has 4 sig figs. The molar mass for hydrogen has 3. So we're going to want 2 sig figs in our answer. And when you do your math through, I think you're going to get around 45 grams for the amount of water that is produced. So again, this is going to be the second worksheet you're going to work on today for me in class. And the final one is going to be going between moles and grams. You might have ones that are moles, moles. You might have ones that are grams, grams. You might have ones that are moles and grams. It's a mixed stoichiometry worksheet, so you're going to have to make sure you pay careful attention to your units. Again, all of the answers are going to be available to you on Google Classroom. You need to check your work, and I will be collecting these from you to see where you are with things before I see you again in class next Monday. So with this particular example, again, it's not balanced. We have aluminum and HCl making hydrogen gas and aluminum chloride. We want to know how many grams of hydrogen gas is made if we have 7.30 moles of aluminum reacting. So if we balance and we look first, we see that aluminum is in balance. We have 1 on both sides. Hydrogen is not. We have 1 on the left side and 2 on the right. We have 1 chlorine on the left and 3 chlorines on the right. Well, if we've already got a 2 in front of the HCl to balance out the hydrogens, but yet we need 3 chlorines, we're going to have to multiply 2 by 3 to get 6. Okay, when we do that, that's going to make us, once we get the 6 chlorines, we need to double the AlCl3 to get 6 chlorines over there. That gives us 2 aluminums on the product side, which means we need 2 aluminums on the reactant side. And since we now have 6 hydrogens on the reactant side, 3 times 2 gives me 6 hydrogens on the product side. So this is one you do kind of have to go back and forth a little bit on. So just make sure with these types of equations that you take your time in balancing them. We are going to start this problem just like we have done the others with what we were given. Aluminum is by itself as a word question. It's just aluminum metal, so we're looking for Al by itself, so the Al on the reactant side. You're also told it reacts. That's a kind of good keyword to know which side of the equation to look to find aluminum on. We want to get rid of the moles of aluminum, so they go in our denominator. And we want to find grams of hydrogen. Hydrogen is being made, so we know it should be on the product side. We're also told it's a gas, and that is by itself, so we're looking for H2. Now that we have that set up, we're going to put our default 1 in front of moles and our molar mass for hydrogen. We just did that on the previous example, 2.02, in front of grams. We're not quite done though because we need to relate aluminum to hydrogen. We look up here, we see that there are 2 aluminums that are consumed for every 3 hydrogens that are generated. So for every 2 aluminums, I need 3 hydrogens. The moles of aluminum cancel out. I multiply across 7.3 times 3 times 2.02, and then I divide everything by 2. This quantity has 3 sig figs. That's a trailing 0. You have a decimal in the number. The molar mass here has 3 sig figs, so we want 3 sig figs in our answer. When we do the math through, you should get something along the lines of 22.1 grams. So that should be the end of the examples that you needed to take care of for your homework, or sorry, for your notes. What I'm going to do now, you're going to get a packet of stoichiometry practice. Give me 1 second and I'll pull it up for you. So you all are going to be working on this sheet. Again, I will have the answers for you posted on Classroom, but you need to have work to get credit. You are turning these in class today. I want to see what you did during class time. You're going to do one involving grams, masses to masses, grams of one substance, grams to another. You should notice, I bet, that these equations look a lot like the ones from the mole-mole worksheet. Again, those answers will be posted on Classroom. And then you're going to be doing the mixed stoich worksheet. I only want you doing up to number 4 on this. I do not want you to do the whole worksheet. I want to see how you're doing with this. So make sure you balance your equations. and that you show your work. I'm going to give you the answers to the calculated values for numbers 1 through 4, so that you can check and see if you've done those correctly. So those problems are what I want you to work on for the remainder of class today. If you finish that up, then you are done for the day. I know I have the crosswords available if you would like to work those as well, from when I've been absent previously. But if you have other work to work on for another class, you can use this time as well to do that. Thanks for listening. Again, if you have any questions, please ask your substitute, or you can leave me a message through email or on Google, and I will get back to you as soon as I can. Have a great day. Thanks for working so hard.